Dah keluar record ke tak? Okay. Assalamualaikum and a very good day to everyone. So basically this is our presentation of our IP project. So we being tasked to build a palm oil based biodiesel plant. So basically in our presentation we will discuss about our design lah. So basically our team consists of 5 respected engineers, which is me, Muhammad Shafiq, Lisa Nadia, Nurin, Divian and Ahmad Haris. So moving on to the next slide, we have the overview of our presentation. So basically we start with introduction, the general design of our processing flow, the simulation of our reactors. So basically this one is the RA part, design of separation process, and go to the conclusion at the end. Okay, so the general idea of processing flow. So basically for our PFD, yeah, definitely we start with the reactant, which will enter the reactor to make our desired product. And from our desired product, we go to the processing separation process to gain our most desired product and to remove our reactants lah. So we must do further purification to remove our residue. So basically the general idea of our processing flow come from this reference. Basically we have many more reference. So basically this one is the major one. So shows in the photo, this is our basically the general flow of our palm oil plant. So from this our reference, we have our own processing flow diagram. So basically it starts with a reactor, enters the reactor, but before that definitely enters a mixer to ensure perfect mixing and so on. So after the enters 2 reactors, which we use CSTR, it enters 1 distillation column, which will separate to distillate and bottom product, which both distillate and bottom product will enters each respective distillation column, which to separate the methanol, which is definitely the reactant that not being reacted inside the reactors, and also to remove the glycerol and to recycle our methanol lah. And also we use membrane to gain our final biodiesel palm oil. Okay, so moving on, we go to the reaction engineering, which the case study will be presented by Divian.
Case study of reaction engineering. Reaction engineering in general plays a vital role in conversion of reaction process engineering. One of the major goals of reaction engineering is optimize chemical reaction in order to get the best performance in a process. The objective of the project to determine the suitable type of reaction and size to produce 3,000 ton per year of high quality biodiesel. The second objective is introduce the strategy to maximize the selectivity and yield biodiesel and minimize the site reaction of production of high quality of biodiesel.
So for process description, first of all, the reaction that occur on the biodiesel production that we use is transesterification. Transesterification is chemical reaction that involve reaction of triglyceride and alcohol with the presence of catalyst, which in our case is tripalmitin, methanol, and sodium hydroxide. There are 2 reactions that will occur, as you can see on the slide. And one is a main reaction that involves the production of methyl palmitic and glycerol by consumption of tripalmitin and methanol. Next slide. And the other one is a side reaction, which is saponification. Saponification it's happened practically if water is present in the reaction. So the water will react with the triglyceride and form diglyceride, which will react with catalyst to form soap and water, which we do not want to produce. And however, to minimize the product from the side reaction, we assume that the feed is dry, which there is no presence of water, to assure that there is no other product manufactured beside methyl ester, or we should call it biodiesel. And we can also pre-treated the feed before entering the reactor to prevent disruption from the water particle. Okay, next slide. The next is the sizing of reactor. We assume the volume of these 2 reactors respectively had been considered as the size of reactor in real life application. So the following assumptions are applied on the manual calculation in order to find molar flow rate and concentration of each component. Okay, next slide. There are two different stoichiometric table for each CSTR1 and CSTR2. For both model, the difference is at its conversion factor, which CSTR1 only converted 44% of conversion, while CSTR2 hold about 88% of conversion rate. So the flow rate and concentration were obtained to calculate the initial volume flow rate and volume reactor in the next slide. So next slide. Okay, last but not least, the volume of both CSTR were obtained by division of initial reactant flow rate times conversion with rate law that we obtained from the concentration of reactants. And therefore, the volume of both CSTR are calculated as you can see on the slide. And that's all from reaction part. Thank you.
Okay, case study for PMS. PMS is a core subject for chemical engineering students. A model is simplified of system, a specific point in the time of mathematical description of physical system based on the fundamental physics. Chemical engineering processes are complicated, hence simulation studies may be used to forecast the statics and dynamic behavior of processing, utilize experts of PMS. The knowledge from this course will be implemented in design reactor separation system for palm oil resources to 3,000 ton per year of high quality biodiesel. The objective of PMS part is to simulate the steady state reaction process using the simulation software. Another goal of this section is to conduct sensitivity analysis by discussing the impact of feed temperature, composition, and flow rate on the reactor performance.
As for the simulation part, this is the symmetry simulation that consists of one mixer, one reactor, two reactors, CSTR reactors, one process calculator, and one pump as well as one heater. The property package used is Uniquark, whereas the components and all the operating conditions is taken from the reaction engineering section. Next slide. This is the inlet streams for methanol and tripalmethane inlet stream, in which the temperature and pressure is kept constant throughout this whole process because it is assumed to be isothermal and isobaric. Next slide. The pump and heater is added to the simulation in order for us to determine and manipulate the temperature and pressure throughout the whole simulation. Next slide. For the CSTR1, the volume and the activation energy is obtained from the reactive engineering part, as well as, next slide, as well as the CSTR2, in which the volume and also the activation energy is obtained from the action engineering part. Next slide. Lastly, we obtained a reactor effluent stream, and we obtained a final conversion of 0.88 in the process calculator. Next slide. There is a derivation error between the symmetry simulation and the manual calculation. The general formula to calculate the deviation error is by subtracting the theoretical value with the experimental value, then proceeding with dividing it with the theoretical value and timesing it by 100%. From this, we obtained a conversion X for CSTR1, which is a 0.88%. Therefore, in addition, we also obtained a CSTR2 conversion of 0.36%. From this, we ensured and obtained that the conversion in total is less than 1%. Next slide.
Okay, moving on, let's discuss the effects of feed temperature on the reactors lah. So basically, as we can see on the graph here, we can see as we increase the temperature of our reactor, we decrease the conversion. So it's not preferable to increase the temperature of our feed because it will decrease our conversion. So moving on, next we have the effects of flow rate and composition of the reactor. So first and foremost, we talk about the flow rate of our methanol. So as we have two reactor inlet feed, so we have methanol and triphlomethane. So we talk about methanol first. So methanol, as we can see from the graph beside here, we got that as we increase the mole flow of our methanol, we increase the conversion of our triphlomethane. So it is preferable to increase the mole flow of methanol in order to increase our conversion. So moving on next, we have the effect of our palm oil, basically the triphlomethane FA0 flow rate. So as you can see in the graph here, as we increase the palm oil flow rate, we decrease the conversion of our palm oil. As you can see here, from the conversion of 0.99 down to 0.5. So it's not preferable to increase the flow rate of our reacted palm oil, basically to increase our conversion. Besides, it will go otherwise. So next off, we go to the separation process, which we discuss the case study from Biodiesel.
Case study for separation process 2. A separation process is used to separate two or more different products from a mixture, although the particular separation design varies based on the chemical being separated. The objective of biodiesel refining operation are to improve the fuel combustion performance, maximize the power delivered to the motor, increase the engine life, and reduce the emission of noxious compound. However, this process produces an aqueous effluent which might have a negative influence of the environment.
Okay, thank you, Divian. For separation process part, we designed three separator column first to separate the unwanted component. And then there is one main separator system for purification process. The chosen main separator system is a ceramic membrane to purify the biodiesel from the impurities contained in the cracked biodiesel. Next slide. This is how a membrane works. In the membrane, the feed entering the membrane is the cracked biodiesel, which contains all the impurities. And then the impurities will pass through the filter inside the membrane and exit as the retentate. And for biodiesel, it will permeate through the membrane and exit as the product. Next slide. This is the specification for the chosen membrane. It is one of the inorganic membrane, and the ceramic membrane is also understood to have higher packing density, which contributes to the lower porosity. And note that these all values are taken from reliable sources. Next slide. Calculation were also made based on the specification just now and also some assumptions. And it was determined that the glycerol remains in biodiesel at the permeate site is about 0.002, which means that the retention glycerol is at 99.8%. As higher glycerol removed, this means that higher purified biodiesel can be formed. And so the design can meet the desired flow rate of refined biodiesel. That's all from Super, but I pass the Divian.
Okay, conclusion. In conclusion, by implementing three core subjects of chemical engineering, which are reaction engineering, process model simulation, and separation process, we can create a reactor separator system for conventional palm oil resources to 3,000 tons per year of high quality biodiesel. From reaction engineering subject, we can able to create a reactor system is designed to meet biodiesel production of our own desire. We able to validate the simulation by comparing with manual calculation using reaction system and provide the derivation error between the simulation and manual calculation. We also get up to suitable design separation process system to improve the quality of biodiesel, and we provide the mass and heat balance flux rate calculation and other appropriate calculation related with the separation unit. Next. Thank you so much.
Okay, nice.